Algebra 1, Chapter 3, Sections 2 and 3, Solving Inequalities. Solving inequalities is exactly the same as solving equations, but with one exception. You must flip the inequality sign anytime you multiply or divide by a negative number. This should be the first example you put in your notes. Go ahead and write the example of x minus 15 is greater than negative 12. Now to solve this, you're going to solve this the same way you solve an equation. You're going to isolate the x. To do that, we are going to add 15 to both sides. The 15s will cancel out, so on the left you'll have x, on the right you'll have a positive 3, and the greater than sign comes straight down. So x is greater than 3. Now when you go to solve this, you need to plot your numbers. With this inequality, the greater than sign, you have an open circle. This is an open circle. It's not closed because there's not an equal sign with it. So you're going to include everything greater than 3, but never equal to 3. So the side that has a number greater than 3 is the side that has a 4. And you're going to shade this all the way up, and that will be your graph. Here is example number 2 in your notebooks. Go ahead and write down the equation x plus 6 is greater than negative 4. And we're going to look for these solutions. To solve this, just like we would solve an equation, we would subtract 6 from both sides. So on the left, we have x. On the right, we have a negative 10. And we see, as we bring the inequality straight down, that x is greater than negative 10. So when we go to graph this line, notice I'm keeping my intervals here even. The interval is a distance from here to there. I'm going to locate the negative 10. Once again, I'll have an open circle because this is not an equal sign in here. It's a greater than sign. And I'm going to look where x is larger than negative 10. Well, the side that has x larger than negative 10 is the right-hand side. And so I'm going to shade that all the way up. Now, the reason it's shaded and not something else is that every number in that location makes the statement true. Whether the number is negative 5 is greater than negative 10. The number 0 is greater than negative 10. 5 is greater than negative 10. All of these numbers are greater than negative 10. All of these numbers make the statement true. In your notebook, this should be example number 3. Make sure this is written down, as is 1 and 2. For example 3, you need to write x over 3 is less than negative 2. Once again, we are going to solve to determine the solutions, and then we will graph the solutions. Well, in this case, x is being divided by 3. So to undo that, we're going to multiply by 3. And what I do to one side, I must do to the other. On the left, we have x. On the right, we have a negative 6. That's negative 2 times 3. And the inequality comes straight down. So my solution set is where x is less than negative 6. When I draw my graph, I'm going to keep that in mind. Again, notice my intervals are pretty even. I'm going to use an open circle at 6. That's because my inequality does not have an equal sign. It's less than. And which side is true for this? Well, the side with negative 7. Negative 7 is less than negative 6. And so that's the side I'm going to shade. So the solution to this is all numbers that are smaller than negative 6. This is example 4 in your notes. For example 4, write negative 3/4 W is greater than or equal to 3. Once again, I'm isolating the variable, so I need to get rid of the negative 3/4. To do that, I'm going to multiply by the reciprocal. And what I do to one side, I must do to the other. So both sides are being multiplied by negative 4/3. As you know, negative times negative is positive. 3's will cancel, the 4's will cancel. So on the left, I get a W. I have a negative times a positive. So that'll be a negative 3/1. Do some canceling. I have negative 4. I still want you to graph this. -0, -1, -2, -3, -4, 1, 2, etc. So at -4, I need to use a closed circle because I have this equal bar. So at -4, I'm going to use a closed circle. I'm going to fill it in. And W is greater than -4. Which side of this line is the greater numbers? Which one make this a true statement? The numbers on the right. So I'm going to shade all of the numbers on the right, including the arrow at the end, to show that all those numbers, whether it is -3 or -3.333, or -2, -1.5, or -1, no matter what the number is along this line, it is going to make this statement true when you put it in place of W. Here is example 5 in your notes. This is a story problem, obviously. You walk dogs in your neighborhood after school. You earn $450. That was silly. Here's example number 5. Please make sure it's marked as number 5 in your notes. You walk dogs in your neighborhood after school. You earn $4.50 per dog. How many dogs do you need to walk to earn at least $75? If you want to learn at least $75, you want to earn more than or equal to $75. So I'm going to make my pointed in point to 75 because that's the smallest amount I want to make. I want this side to be bigger. Well, on the right, I earn $4.50 per dog. So 4.5 times D. To solve this, divide both sides by 4.5 so that you realize that D equals 1667. Now think about this. You cannot walk 16 and 2/3 of a dog. There's no way to walk 2/3 of the dog. Either you walk the entire dog or you don't. Your D needs to be a whole number. Your graph is going to look slightly different. You're still going to have your 16 dogs, 17 dogs, 18 dogs, 19 dogs, and so on. And you have to walk dogs numbers larger than that. But you can't walk partial dogs. So since the smallest whole dog you can walk is 17, you're going to do a dot there. And it'll be a closed dot because it includes the equal sign. D has to be greater than or equal to 16.67. 16.7 has to be less than or equal to D. Well, we're talking dogs. They have to be whole dogs. So your answer can be 17, 18, 19, 20, and then we'll shade this arrow to prove that it goes on, or to exhibit that it goes on. Notice in this case I'm using a discrete graph. Shading the middles because I can't have part of a dog. I can have 17 dogs or 18 dogs, but I can't have 17.5 dogs. Not to walk, at least. This is number 6 in your notes. Take a look at this question and then with sentences, write what you're going to do to solve this and get this. 1 or 2 sentences should be fine. Make sure you know equivalent inequalities. Make sure you know what the addition and subtraction properties of inequality are. You might have to look in your book for that. And then take a moment to grade yourself and how well you can do this. Part 7 in your notes. Taking a look over on the right, I want you to describe the student's first step. Tell me what their error is, and then go ahead and tell me what the correct solution is. Again, check with yourself, make sure you know what inequality, multiplication property of inequality, and division property of inequality are. And finally, take a look and see how well you feel you can solve inequalities that involve multiplying and dividing. The previous one was just on addition subtraction.